Hi everyone, so today we're going to do some exercise of the exercise set. Let's start with question 4. So solve these simultaneous equations. So this is a quadratic simultaneous equation, so for sure we will get, at the end, we will get two pair of solutions. So let's, what we're gonna do here is we're gonna try to substitute the value of x in terms of y into this one. Okay, so what first we will do, write x in terms of y. And we've covered a similar example in the last session, just the one before this one. You can check that out. So x is gonna be 3 minus y. So using the first equation, we do that, and then substitute this one, let's call it 1, and call this 2. 1 into 2. Okay, so when we do that, whenever I see x, I'm gonna write 3 minus y. 3 minus y squared minus 3y equal 1. So, and now I just have to expand this one. So this is minus 3 squared minus 2 times 3 times y plus y squared minus 3y equal 1. And I just have to simply compute this one. So 9 minus 6y plus y squared minus 3y, and I'll move the 1 here as well, because what we want to do is like to solve the quadratic equation eventually, and so we want it to be everything equal to 0. So here y squared minus 6 is minus 9y, and 9 minus 1 is 8. So that is equal to 0. I can either use a quadratic formula to solve this, or factorization. I can simply factorize it. So I need to find two numbers for AC. So A being 1 and C being 8. AC is 8, and B is the one that's next to y. That's minus 9. So I need to find two numbers that when you multiply them together gives you 8, and when you add them together gives you minus 9. So I can think of two indeed. So we have minus 1 and minus 8. So we have y squared minus y minus 8 y plus 8 equals 0. So as you can see here, what we do is we just split it in a way that it will give us, like, eventually will give us like a common factor, which you will see. So this is literally the same thing, but we just split minus 9 into these two terms. So y minus 1, this one, if we were to factorize it, is going to be minus 8 y minus 1 equals 0. So here we have a common factor, and we can factorize again. Y minus 8 equal to 0. So y is either equal to 1 or y is equal to 8, right? And the solutions are eventually, so it's easy for me to use this one to find x. So solutions are for y equal 1. What x will be, so again, we're using this one basically. 3 minus 1 is 2, so x is going to be 2. And for y equal 8, x is going to be 3 minus 8, which is minus 5, I believe. And these are the solutions for this simultaneous equation. Easy and simple. So we shall move to the next one. By eliminating y from the equations, y equal to minus 4x, 3x squared plus xy plus 11 equals 0, show that x squared minus 2x minus 11 is equal to 0. So previously we wrote x in terms of y, and we've eliminated, as you can see, we eliminated x from the equation. In this case, we're doing the opposite. We're gonna eliminate y from the equation, and eventually we'll get here. So let's do that step by step. So for part A, I'm gonna substitute this one into this one. So substitute equation 1 into 2. And that will give us 3x squared plus x. So whenever I see y, I'll replace it by 2 minus 4x. And plus 11 equals 0. So 3x squared plus 2x minus 4x squared plus 11. So what we're doing here, we're just simplifying, right? So this one, it becomes minus x squared plus 2x plus 11. This can be rewritten if we multiply everything by minus 1 from both sides. We'll eventually get x squared minus 2x minus 11 equals 0. And that I've gone to this one because they asked us for this specific form. Otherwise, either are the same thing. For part B, so you can see we've done the same thing and we got to the required equation that they've asked us for. Hence, all otherwise solve these simultaneous equations, giving you answers in the form a plus minus b square root of 3, where a and b are integers. So I believe this one I cannot use the factorization method to solve it, so I'm gonna use the quadratic formula. So use the quadratic formula. I believe everyone is familiar with it. If not, I've got a video on that. You can check it out. So x is equal to, b in this case is minus 2, so 2 plus or minus b squared minus 2 squared minus 4ac, so minus 4 times 1 times minus 11 over 2 times 1, which is 2a, so it's just remains as 2. So x is equal to 2 plus or minus, so 4 plus 44, that's like 88, I believe. No, it's actually 44 plus 4 is 48. So 44 over, no, 48. I don't know what's wrong with me. Over 2. So this one, if we were to simplify, is going to be 1 plus or minus square root of 48 is simply 4 square root of 3, and 4 over 2 is 2, so 2 square root of 3. And eventually we found the answers for x in this form, the given form. We're not done yet. We still have to find y because we're aiming to solve this simultaneous equation, and it's only solvable once you find y and x. That's where you can say, oh, I'm done. So for x is equal to 1 plus 2 square root of 3, y will be, we know it's 2 minus 4x, so 2 minus 4, 1 plus 2 square root of 3, which is 2 minus 4 minus 8 square root of 3, which is 2 minus 4 is minus 2, so minus 2 minus 8 square root of 3. And for the other one, for x equal 1 minus 2 square root of 3, is going to be y equal to 2 minus, so again, I'm referring to this one, 2 minus 4x, so 2 minus 4, 1 minus 2 square root of 3, so it's going to be 2 minus 4 minus plus 8 square root of 3, which is minus 2 plus 8 square root of 3. So solutions are the ones we found right now, so x1 plus 2 square root of 3, y paired with this one, and x is equal to 1 minus 2 square root of 3 paired with this one. So an important thing to note that solutions come as a pair. So yeah. So we've got one more question for today. So we have one pair of solutions for the simultaneous equations. Y equals kx minus 5 and 4x squared minus xy equals 6 is 1p. So that means x is 1 and p and y is p. So that's one pair. Because it's a quadratic simultaneous equation, we have two pairs of solution. So anyways, let's focus on part A and then deal with part B, which we will find the other pair. Find the values of k and p. So, I mean, looking at it, I can't much figure out how I'm gonna find it, but I know this important information. So what I'm gonna do first is I'm gonna substitute those values into the simultaneous equations. So 1p is basically saying x is equal to 1 and y equal to p. So p, for the first one, it becomes p equal k minus 5, and the second one becomes 4, because this one is 1 squared, so it stays as 1. So 4 minus 1 times y, which is minus p, equals 6. I think I'm right about that. Yeah, 4 minus p equals 6. So p is, from the second one, we can deduce that p is equal to 4 minus 6, which is minus 2. Okay, now I know p is equal to minus 2. I can substitute this one into that one and find k. So knowing that, then k becomes, so let's say k is 5 plus p from that one. 5 plus p, so 5 minus 2, which is 3. So p is equal to minus 2 and k is equal to 3. So now that's been done, I can use the normal method as in like proceed as normal to find the other pair. So I'm going to substitute the values of minus 2 and 3 into my simultaneous equation so I can have like a normal one with known values. So y is going to become 3x minus 5. And for the second one is going to become 4x squared minus xy equals 6. Okay, so I'm going to substitute this one, the first one, into the second one. So substitute 1 into 2. You can see, so doing that, so it's going to become 4x squared minus x, so y becomes 3x minus 5 equals to 6. So simplifying, 4x squared minus 3x squared plus minus x times minus 5 plus 5x minus 6. So I'm trying to get a quadratic equation where everything equals to 0 so I can actually solve it basically. So this becomes x squared plus 5x minus 6 equals 0. So I'll solve this one using the factorization method where AC is equal to minus 6. So A, B, and C. These are the coefficients, okay? So A times C is minus 6 and B is equal to 5. I've got to find two numbers that when you multiply them together, it gives you minus 6. And when you add them together, it gives you 5. So I can think of 6 times minus 1. So x squared plus minus x plus 6x minus 6. As you can see here, I've just splitted this one into a more strategic way into like finding a common factor later. So this is just 5x. If you add this together is 5x. So I've done basically nothing, and that's equal to 0. So that's, I'm gonna factorize by x here. I can factorize here by 6. 6x minus 1. So x minus 1, that's a common factor, so it becomes this, and it's equal to 0. Then x is equal to 1. Or x plus 6 equals 0, so or x is equal to minus 6. And indeed, x is equal to 1 because we know that one of the pair of the solutions is 1p. So I'm not interested in x equal to 1 because I need to find a second pair. So I'm going to find a y for x equal minus 6. So the second pair of solution is x equal minus 6. And for y, so y is going to be 3 times minus 6 minus 5, which is y equal to minus 18 minus 5, that's minus 23. And yeah, we've found the second pair of equation and we finished today's questions. So I shall see you in the next one. Bye.